Hello students, welcome to Target IES. Let us continue with module number 12 of RCC, a very important module in which I am going to teach you ESC and GATE questions. ठीक है? So actually I thought of postponing it and make it as I told in the very first module, right? So 11 भी इस तरह से बना लूँगा. But let us continue. Let us finish this GATE syllabus first of all. So in this module number 12, let us see some important GATE and ESC questions. So coming to this GATE questions, they are going to be quite simple compared to that of ESC mains. Okay, ESC means 20 मार्क का क्वेश्चन रहता है ना, तो डिजाइन एस्पेक्ट थोड़ा डिफिकल्ट रहता है. There are two types of questions, I told you, right? There are two type of cases possible in designing. The first case, the dimensions of the beam will be provided to you. You know the B, you know the capital D, and you know the length. All you have to find is amount of steel you are going to provide. In the second case, आपको length बता दिया जाएगा. Length you know the loading condition. You have to find out B and D on your own. ठीक है? B and D आपको पहले पहचानना है. After finding B and D, how much steel you have to provide in that section, you have to find it out. So this case 2 now, it is no one gets the same answer. For example, in the case 1, as the dimensions are already fixed, you have to calculate AST, and if you solve by problems, everyone will get, for example, answer is 1000 mm square, everyone will get 1000 mm square only. And you will input in gate calculator, in gate जो भी बनता है आपका computerized exam 1000 mm square, and computer will correct it. आपके 2 मार्क आपको आ जाते हैं. But if this question asked the second type, because B and D it is upon you, थोड़ा बहुत difference तो चलेगा. Someone will assume B is equals to 0.5 D, someone will assume B is equals to 0.60. It is up to them, right? So there are some assumptions involved. As assumptions are involved, someone will get 1000 mm square, someone will get 1050 mm square, 1060 mm square, like that. So the approximation range is very high, and computer क्या करेगा, answer wrong दे देगा. That's why this B section, the case 2 is not actually possible for gate. Gate के लिए आएगा तो case 1 ही आएगा. ठीक है? So dimensions will be provided to you. You just have to calculate how much steel is provided. Okay, so let us see both cases in detail. But before that, let us revise once. Whenever I am talking about beam dimensions, length, this is your length. Okay, आपको लेंथ नहीं दिखाई देगा. when I am talking about cross section, all you can see is breadth and depth. Depth is represented by capital D. याद रखना, depth is represented by what? Capital D. And there is also one more term which is called as effective depth, which is from top to centroid of your steel. इसे हम क्या कहते हैं? effective depth कहते हैं. Effective depth. And what is this difference? This difference will be your capital D minus small d, or you can call it as your effective cover, effective cover. So total depth minus effective cover आप कर लोगे तो आपको क्या आ जाएगा? effective depth small d आ जाएगा. I hope it is very clear for you. Not at all a problem, right? So this is some basic thing which you have to keep on repeating so that you won't be confused. Okay, so if you have some spacing like this, let us say this is your steel bars. So from centroid of steel to bottom, this is your effective cover. From clear, ये जो clear distance बनता है from the bottom of steel bars, okay, the exposed distance जो भी रहता है, it is called as clear cover, or you can also call it as nominal cover. Nominal यानी minimum cover. Minimum cover towards the end, वो क्या होता है? Clear cover होता है from to the bottom part, to top to the bottom part, whereas effective cover is to the center of your steel bars. याद रहेगा ना? Very simple denotion, but you should not forget it. So now coming to this first case in which section size is given. Okay, length, breadth, depth of beam you already know. You just have to calculate AST. See, you have to make a short note. See, I have already given you short notes of my RCC, right? है ना आपके पास soft copy? Just see it once. Okay, very simple denotion में मैंने already almost everything I have written, all the chapters I have written, so it will be very handy to you. But you make your own short notes also. Let me tell you how to make the short notes for this. Write in stepwise so that it will be very easy for you. Okay, if you are reading these 2 pages, it gets very difficult to remember, right? Exam time में भूल जाओगे बाबा. So let us be very clear. You should write in stepwise my process. The first step, here the dimensions are provided to you. You know the length, you know the breadth, you know the depth already. So the first case is to find what is your ultimate load. Okay, loading condition will also be given to you. How much load it is acting on the beam. Based on that, you have to find out how much steel you have to provide. So first case, you have to calculate ultimate load. याद रखना, first step is to calculate ultimate load. Why ultimate load? अरे बाबा very simple topic है. See, let us say W is your service load. Service load यानी the load which is acting on your body, the virginal load which is acting on your body. But in limit state method, I have clearly said you, we design for what? This service load into some partial factor of safety which will give me my ultimate load. As simple as that. हम उसी के लिए डिजाइन नहीं करते. The load which is acting, we consider the worst case. We are designing for something more. As simple as that. Agreed or not? So W into your factor of safety will be getting your W ultimate. So first thing you have to calculate is W ultimate or ultimate load. How to get it? Your service load into partial factor of safety. That's it. You will be getting partial factor of safety. You will be getting your ultimate load. Once you get your ultimate load, WU, what you have to calculate? You have to calculate your ultimate bending moment. Okay, first step क्या है? Ultimate load calculate कर लो and then calculate. First step में ही लिख लेना bending moment ultimate bending moment. यानी bending moment यानी always remember the moment which is coming because of this loading condition. See, there are two, basically there will be two types of beams whenever you are going for construction. आपको एक मिलेगा cantilever beam, okay, and दूसरा मिलेगा आपको simply supported beam. If nothing is mentioned, blindly you will take it as simply supported beam. If he is mentioned as cantilever, then cantilever लोगे. And loading condition is very easy. You might have studied in SOM and structural analysis, right? There will be a beam and there will be multiple loadings like this, blah 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 blah. Like एक ही beam पे इतने सारे conditions दे देते हैं in difficult problems. But in RCC ऐसा कुछ नहीं रहता. In buildings, while designing, we don't take this type of nonsensical things. Mostly it will be UDL only. क्या रहेगा? It will be UDL only 99.99% of the times, otherwise mentioned. Okay, or you can make it 100%. Okay, it doesn't matter. सिर्फ UDL रहेगा. So it is very easy. You already know if you have a cantilever, what is the maximum bending moment it is induced because of the UDL. That will be, if UDL is W, then WL square by 2, right? If UDL is W, what is the maximum bending moment it is induced in your simply supported beam? It will be at center, and that is WL square by 8. You already know it from SOM and structural analysis, right? I need not derive it. याद है ना आपको? So WL square by 8 आप लिख लेना. See, some people might not have completed structural analysis or SOM. So let me tell you how to calculate once. See, this is not RCC part, this is structural analysis or common sense wala part. Okay, so if you have W, what is the total length? It is L, right? So how much is the total load? Total load is W is kilonewton per meter. इतना kilonewton load add कर रहा है per meter. It is UDL load. So if you are multiplying with the total length, what you will be getting? You will be getting total load, right? Meter cancel, and you will be getting WL kilonewton, which is the total load. So this beam is symmetrical to what? To a point load. W into L, total load जितना आएगा उतना point load acting at centroid. Okay, if L is the length of this load, where will be the centroid? Centroid तो correct बीच में आएगा, which is L by 2 from both distance. Agreed or not? So what is the moment? Moment is nothing but force into distance. Force कितना है? WL. Distance कितना है? L by 2. So what is the moment here? Bending moment ultimate. That will be your ultimate load or ultimate force, which is WU into L into the distance L by 2. How much you got? WU L square by 2. End of story. This is your ultimate bending moment. Sorry, I have a little bit cough. So this is how you will be getting W L square by 2. or if you have some simply supported beam, कहाँ पे रहेगा bending moment maximum? ये तो आप जानते हो ना, it will be at center, right? So how much? W L square by 8. If you don't know, let us derive it. Not at all a problem. So if you have some load like this, W and acting at L meters. So WL is the total load. Total load कितना? Total load. Let us take WU is ultimate load. So total ultimate load कितना? WU into L. So what is the reaction? WU L by 2 and यहाँ पे WU L by 2. कॉमन सेंस की बात है. सो ऑब्वियसली बेंडिंग मोमेंट कहाँ पे मैक्सिमम रहेगा? बीच में रहेगा. सो व्हाट इज दिस डिस्टेंस? L by 2. This distance L by 2, right? So this is the force 1, the upward force, right? Upward force 1. So what is your moment because of this upward force? F1 into distance. Distance कितना है center point के लिए? You can clearly see it is at L by 2 distance, right? So WU L by 2 into L by 2, and this is upward moment. You can clearly see, right? Upward moment यानी I am talking about your clockwise moment. You have a clockwise moment. You have some clockwise moment, and this clockwise moment is WU L square by 4. But now let us see what is happening at the top also you have certain load, right? At the top also you have certain load. Reaction कहाँ गया? Because of this load you are having an anti-clockwise moment. Agreed or not? इस तरह से act कर रहा है moment. Agreed or not? So how much is my anti-clockwise moment? Common sense की बात है. This is W and acting up to L by 2, right? Acting up to L by 2, up to that section. So load कितना है आपका? W L by 2. Where will be this load acting? At the centroid. Centroid कहाँ पे रहेगा? Total distance is L by 2. This distance is L by 4. This distance is L by 4. So force into distance will give you moment. How much is the anti-clockwise moment? W L by 2 into L by 4. So anti-clockwise moment is WU L square by 8. So what is your total moment? WU L square by 4 minus WU L square by 8. How much you will be getting? WU L square by 8. यही तो कहा था मैंने. So if you have a simply supported beam having UDL, आपका diagram कुछ इस तरह रहेगा and this will be W L square by 8. Right? End of story. So the first step is calculate your ultimate load, which is nothing but load into your partial factor of safety. Once you got that, in that step only calculate ultimate load and ultimate bending moment or BMU. Once you get BMU, now you know ये जो concrete का beam है मेरा, ये जो concrete का beam है मेरा, it has to take this much amount of bending moment because this much ultimate bending moment is acting on this beam, right? So my concrete whatever I have should be able to resist this. So obviously I have to check whether my concrete is able to resist it or not. तो कैसे पता चलेगा बाबा? You have to calculate what? You have to calculate your maximum moment of resistance. You have to calculate your MR maximum value, or you can say MU limit. MU limit, your moment of resistance ultimate. Okay, ultimate, U यानी ultimate, M means moment of resistance. Okay, so you just have to calculate your MU limit. कैसे पता चलेगा MU limit क्या है? अरे बाबा पता है तो था लास्ट मॉड्यूल में. MU limit is nothing but your moment of resistance for your balanced section. So that is QU is equals to B sorry, MU limit is equals to Q into BD square. लास्ट मॉड्यूल में मैंने पढ़ाया था ना what is Q value for Fe 250. For Fe 250 it is 0.148 FCK. For 415 it is 0.138 FCK, and for 500 it is 0.133 FCK. So in this condition you know the breadth, you know the depth, you know the capital D, तो obviously आपको पता चल जाएगा what is your small d also. So now blindly now blindly what you have to do, you just have to substitute in this 0.148 FCK will be provided to you. What is the grade of concrete which you are using? That FCK 25 or 30 whatever it is, it will be given to you into B, the breadth into depth square, effective depth का square. So this is your formula. Just substitute, you will be getting your MU limit. Okay, so moment of resistance maximum आपको पता चल जाएगा. This section, the section whatever you are designing, right? So let us draw something in 3D. So this section whatever you are designing, right, it can take MU limit as so much. Okay, so section कितना ले सकता है? MU limit. How much bending moment is acting? BMU, right? To be on a safe side, obviously the resistance power of this concrete should be more than the bending moment which you are applying on it. Common sense की बात है. So if your bending moment whatever is there because of these loads is less than your resisting moment of concrete MU limit, then obviously structure क्या है? Safe है, and you can just go for singly reinforced structure. You can just design it as singly reinforced structure. But in some cases आपको क्या आ जाएगा? आपका required जो आपका moment of resistance है वो कम रहेगा, and moment whatever is acting because of this load will be very much higher. Okay, in that case if your BMU ये भी possible है ना, because if the loads, if you are designing a beam on which a lot of load is acting, then obviously your BMU will be greater than your MU limit, whatever this moment, whatever this concrete section is able to resist. In this case what you have to do, you have to go for double reinforced. You have to go for double reinforced. What you are doing, even in compression zone you are using certain amount of steel. ओके, तो आप क्या कर रहे हो? आपका कंप्रेसिव स्ट्रेंथ बढ़ा रहे हो सो दैट योर MR वैल्यू इंक्रीजेस बिकॉज योर मोमेंट ऑफ रेसिस्टेंस is C into LA or T into LA, right? So what you are doing, you are increasing your compressive force by keeping that steel in tension zone also. I hope it is very clear for you, right? समझ में आ गया आपको concept? So like that you can resist even bigger bending moments. Okay, concept is clear, right? Very clear for you. So if first step is to calculate your ultimate load, then calculate your ultimate bending moment. Second case, calculate your mu limit, right, which is nothing but q into bd square. Very simple. Third step, compare this. Okay, compare your ultimate bending moment bmu and your mu limit. If your mu limit is more, if your resistance is more, then simply supported beam is good enough. Okay, design as design as singly reinforced. अगर आपका BMU is greater than MU है, ब्रैकेट में लिख लेना, if BMU is greater than MU limit, then go for double reinforced. Okay, so this is your step 3. And now step 4, what is your aim? Your aim is to design, right? Design क्या होता है? You just have to calculate what is the amount of steel you have to provide. So for that, you can do two things. Okay, to get the steel AST required value, you can use C is equals to T, right? So fourth step is to calculate AST and your problem is done. So how to calculate AST is a headache. See, you have two things here. C is equals to T कर सकते हो. If you are doing just C is equals to T, let us try to understand. 0.36 FCK XU into B is equals to 0.87 F by AST, right? यहाँ पे two unknowns है. We have XU unknown and AST unknown, right? So there is one equation and two unknowns. Can you solve just by using this equation? C is equals to T, AST आ जाएगा क्या? नहीं आएगा. Then obviously you need one more equation. वो कहाँ से आएगा? See, you know what is the maximum ultimate bending moment which can be generated to this beam, right? Based on that only we are calculating. So what I can do is I can equate my BMU and my moment of resistance. Okay, so what is BMU? Whatever you got from the loading should be equal to moment of resistance, which is C into lever arm. C value कितना? 0.36 FCK XUB into lever arm D minus 0.42 XU, right? You need not write anything. All this thing is already written in your notes. देख लेना उसके बाद. So from here BMU का value आपको पता है. Whatever is contained in real life condition, you already know. You have just calculated it. So just to find out XU, because everything is known. See, FCK is known, B is known, D is known, 0.42 XU is again XU is not known, right? So you just have to find XU right here in this equation. So just substitute, you will be getting your value of XU, right? Once you get value of XU, just substitute in C is equals to T, 0.36 FCK. Now you know the value of XU. Just substitute, you will be getting the unknown value AST. As simple as that. Okay. So to calculate AST, what you have to do? You have to equate BMU and your moment of resistance, and then C is equals to T, right? Like this two step में आपको आ जाएगा. See, instead of writing these two steps, you can directly remember one formula for AST. ये formula कहीं और से नहीं आया. Using this two steps only. In BMU, what you did? BMU is equals to MR, moment of resistance, which is 0.36 FCK XUB into D minus 0.42 XU, right? So what I'm doing is I'm writing XU in terms of BMU, right? So XU is equals to something in BMU आपको आ जाएगा, right? Equation. That equation I'm substituting in C is equals to T. ठीक है? So 0.36 FCK XU जो भी बन रहा है ना इक्वेशन, वो मैं यहाँ पे सब्स्टिट्यूट कर लूंगा डायरेक्टली इन टर्म्स ऑफ BMU जो भी आ रहा है, into B divide is equals to 0.87 F by AST. From here I can get a direct relationship between AST and BMU. Now you need not calculate this step individually. XU का step आपको calculate करने की जरूरत नहीं है. Directly you will be getting a relationship between AST and BMU. What is that formula? Please be careful with this. याद रख लेना. This formula is very important. Give it 5 star. AST is equals to, please write down 0.5 F5 by FCK into BD into 1 minus under root 1 minus 4.6 BMU divided by FCK BD square. So this is your formula, right? 0.5 F5 by FCK BD into 1 minus under root 1 minus 4.6 PMU divided by FCK BD square is your formula. So no need to note it down, यहाँ पे already है, you have to practice it on paper, ठीक है. So this is your formula, very important, give it 5 star, directly आपको आ जाएगा. In terms of BMU, just substitute, you will be getting area of steel you have to provide. Okay, so once you get this AST right, as usual you have to check whether it is in certain limits or not. Obviously it should be less than AST limit. AST limit आपको कैसे आ जाएगा? अरे बाबा सेम है यार, AST limit is for balanced section because you cannot design for over reinforced. If you are providing steel more than AST limit, which is obviously your balanced section, that means you are designing it as over reinforced, and हमारा कोड बुक क्लियरली कहता है इट शुड बी अवॉइडेड, सो मैक्सिमम इट इज AST. हाउ टू गेट AST? आई हैव टोल्ड यू, बैलेंस्ड सेक्शन कैसे करोगे? 0.36 FCK XU लिमिट हो जाएगा फॉर बैलेंस्ड. आई एम जस्ट डूइंग C इक्वल्स टू 3, XU लिमिट B इज इक्वल्स टू 0.87 F5 AST, right? So what will be your AST? From here you can get it, or you can just substitute this directly, right? क्या आ जाएगा आपको? 0.414 FCK by F5 into P. Like this also you can remember. So this is your यहाँ पे क्या रहेगा? XU limit, right? XU limit into B. So like this also you can use. So your whatever AST you are getting using this formula, right? You have to check it if it is less than AST limit or not. Okay. There are two more things for which you have to check. There are two more things for which you have to check. Right? What are this? Let us try to understand. My steel, whatever I got, right? It should be greater than AST minimum. Why AST minimum is provided? See, I have designed a lot of houses. I have designed a lot of beams, hundreds, thousands of beams. In most of the beams, if you are just going for like ground floor wala construction or G+1 wala construction, right? There will be there will be a lot of beams in which even if you are providing AST as 200, it will be more than enough, 200 mm square. More than enough. थोड़े इसमें तो 150 160 भी satisfy कर जाता है. On Stat Pro you will be getting steel as less as 150 160. Even if you are providing one bar of let us say 16 mm square, your entire steel requirement is satisfied. But आप इतना कम नहीं रखोगे, minimum 2-3 बार तो आप रखोगे ही रखोगे. So how much minimum you have to provide? Obviously उससे ज़्यादा आपको रखना है. Minimum कितना provide करना है आपको? Minimum you have to provide is remember this standards already written in your notes, but you have to remember it. So minimum steel whatever you have to provide, AST, we have a formula, AST minimum divided by BD should be greater than 0.85 by F5, or you can directly remember AST should be greater than 0.85 BD by F5. Very important, इतना minimum तो आपको provide करना ही करना है, ठीक है. So even if you are getting steel requirement is very less, minimum आपको थोड़ा बहुत provide करना है, which is 0.85 BD by F5. Why? Because obviously we need ductile properties of my steel, right? अगर एक ही रखोगे तो शायद fail होने के chances बहुत ज़्यादा है. So keeping that in my mind to avoid this sudden failure, I am keeping 2-3 steel bars. Okay, I am keeping 2-3 steel bars. ज़्यादा नहीं रख रहा हूँ, बस within my limits I am keeping it 2-3 bars so that ductility will be maintained and sudden failure नहीं होगा. So my AST minimum should be greater than 0.85 BD by F5. And there is also one maximum limit. Maximum limit is based on your compaction. See what you are doing. अगर आप ऊपर से देखते हो, let us say you are making some column, ऊपर से देखते हो कुछ इस तरह से आपको steel bars दिखेंगे ना while you are constructing. See, if you have a lot of steel bars, then compacting gets difficult in between or in between the spaces, in between your reinforcement. Compaction of your concrete gets very difficult. So a proper bond नहीं form होगा, therefore we have one formula for AST max, that whatever steel bars you have, it should not be greater than 4% of gross area. If this is B, this is your D, 4% of gross area यानी 4%, it is a rectangle, right? 4% of BD से कम ही रहना चाहिए. This is your AST max. Maximum you can go up to 4%. So obviously your A value should be less than this. Okay, समझ में आ गया concept आपका? So AST max should be less than 4% of BD. If you are providing more reinforcement, let us say 6%, 7%, then compaction difficult हो जाएगा. You cannot compact the concrete. I hope you got it right. So AST maximum you can provide is 4% of your gross area. So let us keep it on paper. So your AST value, whatever you got from this formula, 0.5 FCK BD by Fi into 1 minus under root 1 minus 4.6 BMU by FCK BD square. So that should be greater than AST minimum. AST minimum, which is, how to get it? Which is nothing but 0.85 BD by Fi. Okay, 0.85 BD by Fi. Or it should be less than, obviously, and it should be less than, there are two cases possible. One is it should be under reinforced, right? It should be less than balanced section wala steel. How much is balanced section? AST limit वो कितना है? 0.414 0.414 FCK by Fi into XU limit into B. Kitna value? And I told you one more case, which is 4% of gross area. So 0.4% in numerical value will be 0.04 into B into capital D. ग्रॉस एरिया कहा ना, इसलिए B into capital D. सो मिनिमम ऑफ दिस से कम रहना है. मिनिमम ऑफ दिस से आपका मैक्सिमम AST मैक्सिमम इससे कम रहना चाहिए. मिनिमम ऑफ दिस वैल्यू से कम रहना चाहिए. एंड ऑफ स्टोरी. राइट. सो योर AST शुड बी लेसर than these two values and lesser and greater than minimum value. End of story. समझ में आ गया ना कॉन्सेप्ट? काफी सिंपल है. नथिंग टू वरी एट ऑल. So we will solve one problem and it will be more than perfect. So let us see this question. This question is very important, so please give it 5 star. You have to understand this question. So design the critical section of RCC beam of overall section size. So section size is given to you. Breadth कितना दिया है? 350 and depth 750. Right? So breadth 350 and depth is 750. So it is subjected to live load. LL यानी live load. It is subjected to live load कितना? So the beam is something like this. Okay, so breadth 350, depth capital D, which is 750, and what is the length? Length of 6 meters. Right? Length कितना दिया है? The length L is 6 meters. Length आपको क्रॉस सेक्शन में नहीं दिखेगा. All you have to draw is just your B, D, and remember your length as 6 meters. Right? B value कितना? 350. Your D value 750 is more than enough. He is saying this is what concrete? M30 concrete. And what is the steel you are using? Fe415. What is the steel? Fe415. And good thing is he has given you effective cover also. ये value कितना है? 50 mm. So what will be your small d value? Small d value will be 750 minus 50, which is 700 mm. 700 mm. End of story. Everything you got it right. So now comes a very simple thing which you have to remember. What is that? So you have to just calculate AST in this question and your problem is complete, because dimensions you already know. He is telling you to design. So dimensions you already know. B पता है, D पता है. आपको क्या करना है? Just find out AST and problem is complete. Okay. So same above steps what I have thought, you have to follow it. So before that, what was the first step I told you? To find your ultimate load and then ultimate bending moment. So to find your ultimate load, you have to multiply your load and partial factor of safety. Well and good, but यहाँ पे एक बड़ा twist है. Whenever you are taking a load, what are the loads you have to take? You have to take dead load and live load. Even if he hasn't mentioned dead load, you have to take dead load also. In some questions ना, because time factor इतना नहीं रहता है, so directly he will give you dead load value and live load value together, and he will mention that in question. If nothing is mentioned, only live load is given, then be careful. Dead load भी आपको add करना है. Dead load is very simple, Papa. No need to worry. How to get the dead load of a beam if you have certain beam like this? Okay. How to get the load of this beam? How much weight it has? Weight कैसे आएगा? Very simple. Its density क्या हो जाएगा? Density is weight divided by volume, right? So unit weight. So what is your unit? Just give me a second. I'm getting so much cough today. So you can say your unit weight is equals to your weight by volume, right? So unit weight of concrete whatever it is 25 into your volume कर लेना. आपको क्या आ जाएगा? आपको आपका weight आ जाएगा. कॉमन सेंस की बात है, right? As simple as that, right? याद रहेगा आपको. So इतना ही करना है. What is the volume of it? Volume is nothing but it is like some cube, right? You just have to multiply your dimensions. That's it, right? So your length, breadth into depth आप कर लोगे तो आपको आपका वॉल्यूम आ जाएगा into multiplied by your unit weight of your concrete, which is 25. You will be getting your answer, right? If it is a plain cement concrete, no reinforcement, you can take it as 24. unit weight, and if it is RCC, reinforced concrete, then you can take 25, right? So just multiply, you will be getting your dead load. Okay, so once you get your dead load, live load is given in this question as 30 kilonewton per meter. So dead load भी आप kilonewton per meter में ही calculate कर लेना. Okay, so you need not multiply the length, the entire length of 6 meters, just calculate per meter, per kilonewton per meter में दिया live load, तो dead load भी kilonewton per meter में calculate कर लेना. So instead of taking 6, take it as 1. Okay, आपको आ जाएगा kilonewton per meter. If you want total, you can just multiply by 6 whatever the length you have, you will be getting total load. Okay, simple, right? So once you get that, for that calculate your ultimate bending moment and follow the steps one by one, and you will be getting your answer. So let us see this question. A very simple question. First draw your diagram. Length कितने का है? 6 meters का है. And what is the live load? Clearly light, this is the live load, LL, 30 kilonewton per meter. Breadth is given 350, depth is 750. So now let us find our load combination. We have to do it, right? So what is your dead load? Dead load is nothing but your unit weight into volume of your concrete, right? I'm calculating per meter length, right? Kilonewton, I want in kilonewton per meter. That's why length में कितना ले रहा हूँ? 1 meter ले रहा हूँ, because I want per meter, right? If you want to calculate total load also, you can calculate, but आपको remember करना है, units very careful. Okay, so it is up to you. So what you have to do? Breadth into depth into length. You can take 6 meters, you will be getting kilonewton load, or if you are taking just 1 meter, you will be getting kilonewton per meter load, because per 1 meter कितना आ रहा है, you are calculating, right? So I'm just taking 1 into unit weight of concrete. So breadth कितना? 350. See, let us be very careful. 350 है तो आपको meters में लिखना है. How much? It will be 0.35. 750 है, आपको meters में लिखना है कितना? 0.75. What is the length? I'm taking per meter length, right? So 1. Okay, so I'm getting 0.35 into 0.75 into 1 into unit weight of concrete, which is 25. So just multiply, you will be getting how much dead load is acting per meter length. Okay, how much dead load is acting per meter length? How much it is? You must be getting somewhere around 6.56, not 625, it's 6.56. Let us calculate. Calculator कहाँ पे है हमारा? So just give me a second, let me calculate. Here is my calculator. So 0.35 into 0.75 into 1, sorry, into 1 into कितना? 25. So how much you got? 6.56. 6.56 kilonewton per meter. Let us correct it. 6.56 kilonewton per meter. So how much live load is acting? 30 kilonewton per meter. So what is the total load acting? Total load or W acting. So that is dead load plus live load, which is 36.56 kilonewton per meter. So what will be my ultimate load? Ultimate load will be nothing but load into my partial factor of safety, which is 1.5 DL plus LL, right? So how much I am getting? 1.5 into 36.56. I will be getting 54.84 kilonewton per meter, right? So once you got this, just give me a second. What happened to this? It's not scrolling down. Just give me a second. Now it is scrolling down, right? Yeah. So once you got your ultimate load, what you have to do? Ultimate bending moment calculate करना है. It is a simply supported beam. How much is the ultimate bending moment? अरे बाबा, at the center रहेगा कितना है? So WU L square by 8. So WU is 54 point whatever 54.84 whatever you got into L कितना है? 6 meters है, divided by 8, right? You just substitute, you will be getting your bending moment ultimate, which is 246.78 kilonewton meter. First step is complete, right? हमारे 5 step process में first step complete है, only 4 steps are remaining. The first step, bending moment ultimate you got, which is 246.78. Second step क्या था? You calculate your MU limit, right? To see whether the section is singly reinforced or double reinforced. Your MU limit कितना है? It is QBD square. What is value of Q? It is 0.148 FCK, or 0 if it is 250 concrete, if it is 250 steel, or 0.138 or 0.133 FCK. For Fe415, what is the Q value? 0.138 FCK into BD square, right? So वही हम कैलकुलेट करेंगे 0.138 FCK into BD square. So let us let us solve this. So 0.138 FCK कितना? It is M30 concrete, so 30. B कितना? 350. And what is D? D is your effective depth. Effective depth कितना? 700, because 750 is total depth. And he has said effective cover is 50, so this depth is 700, so 700 ka square, and just multiply, you will be getting 710.01. So let us see BMU value and MU value. MU value कितना आ गया आपका? 710, right? So your BMU is around 250 and MU limit is 710. Clearly you can see your resisting moment of concrete is 710, and because of the applied load you are getting a moment of 250. So obviously 250 जो है आराम से ले लेगा, because it can bear up to 710, agreed or not? So obviously you need not provide any steel in the compression zone. Singly reinforced structure ये काफी है, right? So you can clearly see, as BMU is less than MU limit, the section is designed as what? Singly reinforced rectangular section and under reinforced section. More than enough, right? So let us go with finding out how much steel you have to provide. Now you are very clear कि it is a singly reinforced structure. You know the B value, you know the D value. You just have to find out what is the amount of steel and problem is completed. So what you can do two steps now. One is to get AST, you can do your BMU is equals to your moment of resistance, where moment of resistance is C into lever arm. यहाँ से आपको XU लेना है. Using this XU, you have to substitute in C and T, and T is your 0.87 Fi AST, right? From here you can get your AST. It is up to you, like this, or you can substitute in direct formula. डायरेक्ट फार्मूला 0.5 जो भी था फार्मूला, सो वो फार्मूला में हमें सब्स्टिट्यूट करना है. व्हाट इज दैट? 0.5 FCK BD डिवाइडेड बाय FI इनटू 1 माइनस अंडर रूट 1 माइनस 4.6 BMU डिवाइडेड बाय कितना? ओनली इसका डिवाइडेड बाय B, यहाँ FCK BD स्क्वायर, इफ आई एम नॉट रॉन्ग. एक बार क्रॉस चेक कर लेना, काफी इंपॉर्टेंट फॉर्मूला है, यू शुड नेवर फॉरगेट इट. 0.5 FCK BD by FI into 1 minus under root 1 minus 4.6 BMU divided by FCK BD square. So directly also you can get it. Up to you what method you want to follow. Let us do in both the ways and check. So to get your AST, what you have to do? You have to get your XU first. XU first calculate करना है. How to get your XU? Your BMU 250 जो भी था 246.78. So this should be equals to your moment of resistance 0.36 FCK XUB into your lever arm, which is D minus 0.42 XU. Right. So from here try to calculate what you are getting XU. Pause the video, do it. Calculation काफी important है. You should adjust to calculation. You will get 99.16 mm. So once you got it, C is equals to T कर लेना. 0.36 FCK XUB is equals to 0.87 FI AST. From here you can get your AST value. So just substitute and check what is your AST you are getting. 1038.15 mm. Okay. Now check the alternate formula जो मैंने आपको पढ़ाया था in terms of BMU directly. You need not do any such two steps. Directly आपको इस formula में substitute करना है. BMU कितना? 246, 247 जो भी आया था आपको. Right, you just substitute. FCK is 30, B you know it is some 350, D value you know it is 700, FI is 415. So 1 minus 4.6 BMU is 247 something, जो ऊपर वैल्यू आया वो वाले, डिवाइड बाय FCK again 30, B value is 350, T value is 700 उसका स्क्वायर. So once you are doing this substituting in this, you will be getting exactly same answer. थोड़ा चेंज रहेगा, like पॉइंट में चेंज रहेगा. You will be getting exact same. Okay, you will be getting exact same. So 1038 ही आपको आने वाला है फिर से. Okay, so this is your steel which you have to provide. But let us be very careful. The steel whatever you got is in our limits. It should be greater than AST minimum and it should be less than AST maximum. Right. So AST minimum कितना है? It should be greater than 0.85 into dimensions B into small d divided by B into small d. याद रखना 0.85 B into small d divided by FI. बस इतना सा है. And AST maximum, which is obviously it should be less than AST limit value and 0.04 of BD. B into capital D gross area. ये जो एंटायर सेक्शन है इसमें 4% से ज़्यादा स्टील को ऑक्यूपाई नहीं करना चाहिए. मैक्सिमम एरिया विच इट कैन टेक इन माई रेक्टेंगुलर सेक्शन इट इज 4%. So 0.04 B into D. End of story. Right. So let us try to calculate AST. मिनिमम कितना है 0.85 इंटू बी वैल्यू 350, डी वैल्यू 700 डिवाइड बाई एफ आई विच इज 415. कैलकुलेट करके देखना 501.8 mm². See 1038 is greater than 501, right? Then you are safe. First condition is satisfied. Now let us see AST maximum. Now let us see AST maximum. So AST maximum कितना है? You have to calculate AST limit. How to get it? 0.414 FCK by FI into XU limit. XU limit value you know, right? What is XU limit? This is 415 concrete. So it is 0.53D for Fe250, 0.48D for Fe415, 0.48D. So 0.48 into D value which is 700 into your B value. B value is 350. Just substitute. You will be getting 3519 something mm². Okay, 3519 mm². And obviously you have to check for 4% area also. 4% area कितना आ जाएगा 0.04 BD. So it is 10,500 mm². Just calculate. B कितना 350, कैपिटल D कितना 750, right? Into 0.04 10,500 mm². So it should be less than these two cases. Okay, so obviously it should be less than what value? 10,000 से तो कम 3,519 है. So इसके नीचे रहना चाहिए. So the steel whatever you got in this case, it should be greater than how much value? 501 or let us say 502. This is AST minimum, and this should be less than 3,520. Let us take this is AST maximum, right? So our answer was 1038. Therefore it satisfies both the cases and our answer is correct. Now if you are getting any other values, then your answer is something wrong, right? Something wrong. समझ में आ गया ना कंडीशन? आई होप इट इज वेरी क्लियर फॉर यू. नाउ लेट अस ड्रॉ दिस सेक्शन. सी इतना काफी है आपको एग्जाम में, बट इन सम कंडीशन इन योर ESC मेंस you should not just give area of steel. Okay, area of steel you have to provide is 1050 mm², whatever you got, right? कितना आया था एग्जैक्ट 1038 mm². इतना काफी नहीं है. You have to provide 3 bars of 25 mm diameter, 4 bars of 20 mm diameter. कितना प्रोवाइड करना है आपको क्लियरली कहना पड़ेगा. You have to tell how much diameter you are taking and what is the spacing between the steel bars. Okay, what is the clear spacing between these steel bars you have to say. Okay, so basically this clear spacing, whatever you have clear spacing, what is this effective spacing? The spacing center to center spacing between this bar, center to center spacing यानी from center of this to center of this, generally 60 to 70 mm से कम नहीं लेते हैं. Okay, center to center spacing is generally 60 to 70 mm. and this clear spacing what you can see, right? ये जो डिस्टेंस बन रहा है बीच में, दिस इज कॉल्ड एज क्लियर स्पेसिंग. क्लियर स्पेसिंग कितना रहना चाहिए? सी द एग्रीगेट्स विच यू आर यूजिंग इन कंक्रीट में एग्रीगेट हम यूज करते हैं ना. इफ यू आर यूजिंग 20 mm कंक्रीट, 20 mm एग्रीगेट वाला कंक्रीट, देन वी हैव टू लीव little bit more so that concrete can actually pass through in between these steel bars. Okay, so 20 mm plus 5 should be the minimum distance between two steel bars. So what should be this distance? 25 mm minimum if you are having this 20 mm aggregates. I hope you are getting the concept right. So diameter of your aggregates plus 5 mm, you have to leave clear space. Okay, that is the clear space. And what is the effective space in general? Center to center space, that is 60 to 70 mm. I hope it is very clear for you. Basically इतना हम रखना पड़ता है. Okay, so clear space cannot be less than the 25 mm. Done? समझ में आ गया? So like that you have to arrange your parts. Concept is very clear, right? So I have given the theory also. Please read it. In general, how much clear center to center, C by C means center to center spacing. So if you have one bar, this is the center, second bar center, so this distance is called as C by C. Okay, so in general 60 to 70 mm C by C spacing is sufficient for compaction and for free movement. And what is the minimum clear spacing? If you have two bars, this will be your clear spacing, the gap between these two bars. So that should not be less than 25 mm if you are taking 20 mm coarse aggregates concrete. Okay, so now how many steel bars you are providing? Let me tell you something interesting here. let me tell you something interesting here. What is your breadth? See, you have to arrange your steel bar something like this, right? What is this breadth? This breadth is 350 mm. I have told you what is generally whatever you are getting this effective cover, that was 50 mm, right? याद है ना आपको? So if I am arranging my steel bars like this, okay, what should be this distance? This distance to the center, it is 50 mm. It is given in the question itself, right? So this is 50 mm. Okay, so this is 50, this is 50. बीच में कितना बचा? 250 mm, right? Here you are getting 250 mm. Now it is up to you how many bars you want to provide. You can provide 3 bars, 4 bars, 5 bars, but you have space of 250 mm. Remember this, okay? Remember this properly. So how many bars you can provide? It is very simple. If you are providing 3 bars, if you want to provide 3 bars, diameter हम बाद में देखेंगे. But if you are providing 3 bars, then this distance, whatever you have center to center distance, you are dividing into 2 parts. यहाँ पे एक आएगा, then you are dividing its 250 into 2 parts. Agreed or not? So if there are 3 bars, then whatever you are getting, this distance, the end to end center का distance जो भी बन रहा है 250 mm, divided by how many parts? 2 parts. Similarly, if you want to keep 4 bars, if you want to keep 4 bars, okay, if you want to keep 4 bars, you are dividing this 350 into how many equal parts? You are dividing this 250 into how many equal parts? 1, 2, 3. So if you are to keep 4 bars, then what is your C by C spacing? Center to center spacing कितना हो जाएगा? 250 divided by 3. If you want to keep 5 bars, similarly 250 divided by 4. Similarly, if you want to keep 6 bars, that will be 250 divided by 5. I hope you are getting it right. So 250 divided by 2, 125 mm. Yes, well and good. You can keep 3 bars also. Nice. If you want to keep 4 bars, 250 divided by 3. 250 divided by 3 कितना है पापा? 250 divided by 3. So you will be getting some 83.33, which is also good. You are getting 83.33. I have told you it should be minimum of like 60 to 70 mm, right? So this is also good. And 5 bars अगर आप provide करना चाहते हो, 250 divided by 4. 250 divided by 4 how much? 25 divided by 4. So you are getting 62.5. Even this is good. Even if you want to provide 5 bars, so that 62.5 mm center to center spacing are even this is acceptable. But if you are providing 6 bars, 250 divided by 5, which is 50 mm, इतना कम आप provide नहीं कर सकते हो. So there are only 4 conditions possible. So you need not do this in examination hall. Okay, you need not do this in examination hall. You can just write down whatever you feel which is correct. Okay, but यहाँ पे मैं आपको समझा रहा हूँ. Okay, in detail I am just explaining you. There are 4 such possible cases now, or sorry 3 such possible cases now. You can provide 3 bars. Minimum आपको 3 बार basically provide करना पड़ता है. ठीक है, if you are seeing any question, basically 3 बार आप provide करते हो. In some cases 2 bars will also be sufficient, but minimum generally we go for 3 bars. Okay, so 3, 4, 5, 3 conditions are possible. Okay, if you are providing 3 bars, center to center distance कितना? 125 mm. 4 bars 83 mm something. 5 bars 62.5 mm something. Okay, now if you are providing 3 bars, how much diameter the bar should be? How much diameter of the bar should be? AST कितना है? 1038. If you are providing 3 bars, 3 into pi by 4 times the diameter square, it should be 1038. We will be seeing such that आपको diameter आ जाएगा. Okay, आपको diameter आ जाएगा. So if you are providing this 3 mm bars, so you will be getting somewhere around 22 diameter. Let me cross check. Pi by 4 into d square is equal to 1038 by 3, right? So 1038 divided by 3 कितना आ गया आपको? 346, right? So 346 should be your area of each bar. Pi by 4 d square should be 346. So d square कितना हो जाएगा? 346 into 4 divided by your pi value, which is 440, right? So d square is 440. So इसका square root कितना है? 20 into 20, 440. I know it, right? So 20 into 20, I got some 400. So I want something 440. So my diameter should be greater than 20 mm. मैं देख के बता सकता हूँ, right? My diameter should be greater than 20 mm. So what is the size available for you? 22, right? So I can take 3 bars of 22 diameter and it will satisfy. Let me cross check now. Let me cross check my calculator. Where is my calculator? So I have taken 3 bars of 22 mm, right? So 22 into 22, into pi divided by 4 into your 3 bars, right? I'm providing 3 bars. So I'm getting 1140. 1140 is clearly greater than your 1138. तो मैं आपको कितना प्रोवाइड कर दूंगा 3 bars of 22 diameter. I hope it is very clear, right? Make sure that your value is greater than this, but very marginally. ऐसा नहीं है anything greater than 1136 is good, right? In that range आप ले लोगे 1200 1300. Don't go like that. Okay, keep the value as close as that. This is a good answer, so I will be providing this. Okay, I will be providing this. Okay, or you can also provide, I have told you 4 bars, right? 4 bars with center to center spacing of some 83 mm हमें आया था ना. 4 bars with center to center spacing of 83 mm. So if I am taking 4 bars, 4 into pi by 4 into d square, I don't know what is this d, so is equal to 1038. So my pi by 4 or my d square, whatever it is, it should be 1038 into 4 by pi divided by 4. 4 cancel, so 1038 divided by pi. So let us cross check. So let us open our calculator. 1038, what I want, 1038 divided by pi. pi divided by pi कितना आएगा 330 आएगा 330. So if I am not wrong, 18 square is 324 something, right? So we need diameter greater than 3 diameter greater than 18, because 18 squares is 328 if I am not wrong. So diameter अगर आप 18 ले लोगे तो कम पड़ जा रहा है. So obviously you have to go for something greater than 18. You can keep it as 20. 4 bars of 20 mm diameter, right? 4 bars of 20 mm diameter. Let us cross check. 20 mm square, which is 20 into 20 into pi divided by 4, right? You are getting area into, I have told 4 bars. So I get 1256, which is acceptable. I want something greater than 1038. I got my answer. So I am providing 3 22 mm bars, or I can also provide 4 bars of 20 diameter. But now here is the case. Here is the case. You can provide any one of this and your design is correct. आप चाहे तो 2 bars of 28 mm diameter कर लेना, आपका एरिया satisfy हो जाएगा. It will be greater than 1038. If you are providing 2 25 mm bars and one 12 mm bar or whatever different dimensions, then also it will be satisfied. If you are providing 322 mm bars, it will be satisfied. 420 mm bars, it will be satisfied. But let us be very clear, which is the most accurate thing is which is greater than this but closer to that value. Okay, because steel is costly. Remember, concrete is cheap, it is cheap, स्टील इज कॉस्टली. स्टील आपको जितना रिक्वायर्ड है उससे थोड़ा ही ज्यादा प्रोवाइड करना, ज्यादा प्रोवाइड मत करना. दिस इज थिंग विच यू हैव टू रिमेंबर. सो हियर 322 में मुझे आ गया था 1140 समथिंग, राइट? एंड 420 में मुझे आया था सम 1250. सो विच वन वुड बी प्रिफर्ड? दिस वन शुड बी प्रिफर्ड एज अ डिजाइनर. फर्स्ट वन इज सेफ्टी. You have to always consider safety. What is the second thing you have to consider? Economy. So obviously you have to go for something these two in this condition. You can check for like this also, but इतना ज़्यादा time waste करने की ज़रूरत नहीं है. Use your common sense and take the answer. Okay, you need not check how many bars you can provide all the time. Just do it within a minute. Okay, आपको बस calculate करना है. I'm just teaching you first problem, इसीलिए इतना time लिया. Okay, I hope it is very clear for you, right? So after that, write down. You can write these cases like this. After that you can say, I am considering 322 mm diameter bars with center to center spacing with c by c spacing. कितना आया था 3 bars के लिए? कितना था? 125 mm. 125 mm. So like this you have to write down. This is your design complete. I hope you got it right. So this is your problem. Now next we have a second case in which section size is not given and AST is also calculated. See, I am teaching from a lot of time, right? It's more than like 1 hour. So what I will do is, I will just give you a brief introduction how to do, and you can just do it. Okay, same steps रहेंगे, everything is same, but B and D values you don't know, right? B and D values you don't know. So what you can do is, you can imagine certain values for B and D. So what is that values? The value for B and D should be in the range of 0.3 to 0.7. If you are taking B by D ratio, so B by D ratio less than 0.3, that means काफी लीन हो जाएगा, रेक्टेंगल कुछ इस तरह से बन जाएगा, right? So what is happening? there could be a chance of lateral buckling under action of load. Okay, there could be, so your beam will be something like this, and when the load is acting there could be lateral buckling. Okay, कुछ इस तरह से buckle हो सकता है because slenderness ratio is very high. right right, what is happening here? Let us try to imagine this is your length and this is your breadth and this is your depth. When the load is acting कुछ इस तरह से buckle होने के chances है, right, and your structure can fail. To avoid that we are not going less than 0.3, we are keeping it as a proper rectangle. Okay, very clear. And if you are going more than 0.7, yani it is getting something like this, almost equivalent to square 1, right? So your B value is almost 0.7 times or greater than 0.7 times D, and this is your D, and this is your D. So it gets almost like square. So even square type of beams are not what encouraged. Why? Because what is your moment of resistance? Moment of resistance is C into your lever arm or T into your lever arm. So more the distance, if you are taking rectangle, ये जो lever arm है, that will be more. If you are taking square, more area is something like this, your lever arm distance is less. So moment of resistance is less for square compared to that of rectangle. So for obvious reasons, it is preferred to design your beam as a rectangle. End of story. I hope you got it right. So B by D ratio is generally kept in the ratio of 0.3 to 0.7. If you don't know, just take it as B value as 0.5 D, and remaining cases are one and the same. Okay, remaining cases are one and the same. So you can just calculate your D value by equating BMU is equals to MU limit. यहाँ से आपको D value आ जाएगा. So once you got D value, your B value is 0.5 D. So now you know the dimensions. You just have to find out what is your steel. How to get steel? Same here, ultimate bending moment, then compare with your MU limit. If it is less, then you can just use the formula for AST. Okay, just use the formula for AST. Once you get that, end of story. Once you get that, end of story. आपका steel आ गया, आपका B आ गया, आपका D आ गया. D कैसे आएगा? BMU is equals to MU limit. You just have to substitute. You will be getting your D value, and B you can take it as 0.5 times of your depth. Okay, or you can take any value in between 0.3 to 0.7, but generally 0.5 ले लेना if nothing is given. So end of story. Once you got your steel, problem is solved. So do one question. I have given this question here, try to solve it. Okay, try to solve it, and once you got the area of steel, compare with area minimum also, A minimum and A maximum. Okay, your area should be in between these two values. End of story. I hope you're perfect. 3 chapters are done. Next chapter is going to be very simple, which is doubly reinforced rectangular section. Okay, so here we are also getting some steel in my compression zone. Why and how we will study in the next module. Have a nice day. See you in module number 13.